Waiting for Hindustan. Start stream. Okay.
भेजो
भेज दो।
कैसे भेजो
भेज बेचारा भी तो नहीं।
डिले कम करना पड़ेगा
हाँ? कुछ ज्यादा ये वेटिंग फॉर हिंदुस्तान स्टार्ट स्ट्रीम ओके
भेजो
भेज दो।
कैसे भेजो
भेज बेचारा भी तो नहीं।
देखो
डिले कम हो
हेलो हेलो हेलो
चलो रन करो।
आ गया तुम्हारे पास आने लगा क्या आ रहा है देखो
अब यूट्यूब का स्टूडियो खोलो बंद कर दिए। अब मेरे को भेज मैं भी कंपोज कर रहा हूँ।
अब बताओ क्या आ रहा है
अभी तो वही जो बोल रहे थे आप पूछ रहे थे क्या
आएगा आएगा
वीडियो को स्लो चल रहा है। अच्छा वही बता रहा हूँ। अच्छा
शेयर तो बस वो हो रहा था ना मैं बीच में हो रहा था स्ट्रीम लैब्स हेलो
बोलो ना।
yeah so it's been a long time since we were planning to organize some sessions that are proposed by some Microsoft products. So now we have the Hummingbird after kafi sara wait. So we have waited for like 6 months after the lockdown since we have planned for like to do something. So now we are here with the thing that is presented to you by Microsoft Labs. And anyone vegan here? So if you are, kindly don't feel offensive because we are going to cook hummingbird today. So yeah, what is hummingbird? So hummingbird is a library that is proposed by Microsoft for accelerating your traditional machine learning models so that you can convert them to deep neural networks and gain some of the advantages presented to you by Microsoft's like you can use your GPUs, you can like use the DNN optimizers and all. So let's continue. So yeah, what does hummingbird signifies? Yeah, we all know hummingbird is a kind of bird found in the American continent. So what? So when Microsoft were planning to give it some name, give this library some name, so they thought about some characteristics of this library, and then they compared it with some kind of animal or bird, so that they can give them the name. So Hummingbird are typically sized between 3 to 5 inches. They are not so big. They are one of the smallest kind of birds present in our world. So if so what we can signifies from the hummingbird? The significance of the size in the library is because of the size of our traditional machine learning model. The traditional machine learning models, like we have linear regression, logistic regression, random forest, and all, they sized too less if we compare them with neural networks. So that's why they named it like this. Then the second thing, hummingbird are the only types of bird that can sustain long-term hovering, and they are acrobatic flyers that can fly also backward and change their direction more significantly. So what does it signifies? As if you know what is neural network and how neural network works, we know that there is some loss function. We know about the loss function. It will be calculated according to the output, the true output, and the output you have predicted. So after that, there is some backpropagation kind of thing that updates the weights of the tensors so that in the next iteration, the output will be optimized. So that back propagation and then again front propagation or for forward propagation, this change of direction signifies how hummingbird's characteristic is while flying. Then the third thing we have that hummingbird are fighter pilots of avian world, diving, weaving at speed of 55 km per hour. That is like too much for a 3 to 5 inch tall tree bird. That is like I think it's quite fast. So what does it signifies? The significance of the speed of hummingbird signifies the efficiency of neural network and the time it takes to compute a single tensor computation. That is a way faster than we what we do in traditional machine learning models. So this is the significance of machine learning, hummingbird in machine learning. Then what we have? What is hummingbird? Okay, so as we talked about it, that hummingbird is a bird and all that things are different. Don't think about that. So what we have now, Hummingbird ML is a library brought to you by Microsoft Research Lab, and this library facilitates the conversion of traditional machine learning models into tensor computations to take the advantage. Okay. Then the third point we have is that implementation of hardware acceleration like GPU. We all have some kind of GPUs or CPUs in our laptops that we get from our college. So they have these kinds of GPU processors. अबे स्ट्रीम हो रहा है क्या? अभी आवाज आ रही है? मुझे तो नहीं लग रहा कि नहीं आ रही है क्योंकि मेरे हॉटस्पॉट से कुछ कनेक्ट नहीं है.
पापा वाला सेट हो गया। ये मैं कर लेता हूँ, आज तक
GPU
दी हुई
and
गड़बड़ टीम में।
TPUs. So if we have GPU and we are not using it, then they are like nothing for us. So what we can facilitate from the GPU we got from our college is that now we can train our machine learning model with GPUs, like traditional machine learning models with GPUs. Before that, when the model you trained is of scikit-learn library, that models are not trainable in GPUs. They only support CPU as a hardware accelerator. So for this, for getting this advantage, we have Hummingbird, which will convert your traditional machine learning model to a PyTorch framework so that we can get the advantage of CPU, GPU, and TPU, all of them. Okay, so why Hummingbird? So a few of my friends were asking that like we have XG boost for better computation, like we can use GPU as a hardware accelerator in XGBoost too. So why do we use Hummingbird? So XGBoost is a different thing. It is a kind of ensemble learning technique, and Hummingbird is a different thing. You can't compare them, but we will like give you the ideas about that. So why Hummingbird? Hummingbird converts your traditional machine learning model to DNN. That thing is not done in XGBoost. Okay. And with Hummingbird, when you get the conversion of neural network framework, then you can use some kind of uh, advantages of neural network that neural networks enjoy. Then we have the fourth point is that we do not have to re-engineer our model. Like when we are converting our traditional model to machine learning to PyTorch framework, we don't actually have to do something. Like it is a three line of code that will convert all your things. You don't need to worry about that. It's a simple thing. You just have to import a function that will do the work. So, what are traditional machine learning models? Okay, so I have been talking about it from so long that traditional machine learning model. So, what is a traditional machine learning model? So, traditional machine learning model is what? It's like a basic maths we do. Like you can see, we have a decision tree here, and this decision tree is nothing but a probability tree that we have studied in our probability and statistics classes. Like you compute every bit of decision nodes and then you will get the output. It's simple. Then we have something like linear regression. It's nothing but a linear equation that will do the work for you. Then we have logistic regression, which have a fundamental mathematic equation of sigmoid function. So these are the traditional machine learning models. Then, if we come to neural network, so neural network is a different kind of thing than what we see in our traditional machine learning model. So, if you want to know like how neural network works, so working of neural network is two different. Like mathematics cannot define it, but we will try to enjoy the maths part. Okay. So how neural network works? Okay, so like you can see here, we have different types of dendrites here. These dendrites takes the output from other neurons and it will pass it to this. There some computation will be done here. After that, the cell body will do the computations. After that, it gives the output with different weights to other neurons, and the other according to what is the significance of the output and the neuron. Like the neuron which helps to facilitate the moving of your hands will get a better weightage than the neuron which is used to control your legs when you are using your hands. So these are the significance of weightage in neural networks. Then yeah, we can see like every neuron here present is connected with every other neurons, and in our brain you know that there are millions of neurons in there. So this is what biological neural network. This is how a biological neural network works. Now, what is artificial neural networks? So as we have seen there, like how biological neural network works. So now we can take the intuition from biological neural networks and we will implement it in our artificial neural network. Okay. So how it works? We have different weights. Let us suppose we have four weights in here. Okay. So while working with the four weights, you have four kind of inputs. Okay, that will be assigned with some kind of weight. Initially, in neural network, artificial neural networks, the weights are assigned randomly, like they are not fixed. Then the transfer function adds up all the weightage with its input and it gives it to the activation function, and the activation function performs the computation you need, and here the loss function will be calculated, and to get a better loss function we do back propagate, updates the weight, and then we continue the thing. So now you have seen what is traditional machine learning model. What is neural network? How neural network works? So this is what Hummingbird do. We have a traditional machine learning model that is a decision tree. We have artificial neural network of the same thing. So it's what it is. Just you can see Hummingbird converts this traditional machine learning model to a neural network. You can see it like they have four decision nodes, then they have eight output nodes. Then here it is the output, which is one we'll get here. So coming to the installation part of the Hummingbird. So there are some prerequisites for installing Hummingbird. So the prerequisites are you should have a PyTorch library in between 1.4.0 to 1.7.0, which is the latest version. Don't use the version older than 1.4.0. It will not work. Mm, you should have Python with a better version than 3.5. So I would request you to install Hummingbird ML's version of 31st October, that is 0.0.6, because the latest version we got on 10 November maybe, it's not working good. So try to install pip install Hummingbird equals 0.0.6. Okay. And if you want to use XGBoost or Light GBM, then you should go for extra. Then here you can see the difference between different kind of models. Like here we have a scikit-learn model, which is trained already. We are predicting some bits. So how much time it is taking? It is taking 1.07 milliseconds for the computation. Then we are converting our model to Hummingbird PyTorch frameworks model, and we are getting the output with CPU computation, that is 444 microseconds. So you can see the time difference between them. It is like a good difference. Then what we are doing here, we are moving to GPU, and when we compute it with GPU, we are getting even a better output of time, that is 291 microsecond, which is like a good output. Then we were talking about XGBoost and Microsoft Hummingbird, like how they are same, how they are different. So before explaining you the difference, I would like to explain you what is ensemble learning. So we are jumping to that slide. So what is ensemble learning? Ensemble learning are basically of two types, that is bagging and boosting. For bagging, we have some examples like random forest. Random forest classifiers are a type of model that are made by connecting different kind of decision trees. Different kind of decisions tree get attached parallelly, and they compute the outputs. And when we sum up the output and we get the probability of the output, uh, wait, let me explain it briefly. So let us you have a task and the output will be 0 or 1, like if we have a bank churning problem. So one, where one means the customer will leave the bank and 0 means the customer will not. So let us suppose we have 5 decision trees in our random forest classifiers branches attached parallelly, and we are getting output 111 from first three decision trees, and we are getting output 00 from the next two decision trees. So if we sum up the number of ones, we are getting a probability of 3 by 5, and when we sum up the 0 bits, that are 2 by 5. So what we can see here, the probability of 1 by 3 by 5 is better than 2 by 5. So the random forest will give you the output of 1 because it has a better probability. And then if we compare it with boosting, boosting is a different kind of ensemble learning technique, because here the models are attached sequentially. So how boosting works? Let us suppose we have some data. Okay, it is clean data already. and we have given it to a model, and we are checking the accuracy. If the accuracy is not 100% and some of the data tuples are not giving the correct output, so we give them a better weightage and pass it to the next model. We can like connect a number of weak learners to form a strong learner. Like we can consider this whole model as a strong learner, and all the smaller models connected in here are weak learners. So when we pass in the data to the next model, the data we have passed should be weighted more. The data that are not calculated correctly. So after that, you get the idea how bagging works, how boosting works. So what we can do now, we have three kind of boosting techniques normally. That is adaptive boosting, that is gradient boosting, and that is XG boosting. So adaptive boosting and gradient boosting are something that can be trained on CPU, and gradient boosting is a kind of slow algorithm because it like combines a number of models and passing it to next model. These things takes time. So what we can infer from here, what camera थोड़ी on रहेगा, what we can infer from here that gradient boosting and adaptive boosting are kind of slow. So what should we do? We have XG boosting, that is extreme boosting, which allows you to use GPU as a hardware accelerator so that you can facilitate your training. So now you know what is XG boost. So we can now compare it. So Hummingbird supports GPU as a hardware accelerator, and XG boost also supports GPU as a hardware accelerator, and both are kind of perform same. Then we have the second difference, that is Hummingbird converts the model to deep neural network, but the XGBoost ensemble learning technique do not converts the model to sequence to deep neural networks. It will just sequence the same traditional machine learning models. Then in Hummingbird, this is like a very big disadvantage of Hummingbird. That is, it is too expensive to get trained. Like if you see, when like we will be doing this further. So when we train Hummingbird with GPU of a model that is like not too big, it is a basic model. So it's taking a GPU resource of 5 GBs, and if we compare it with a XG boost, that is taking 0.5 GB of the GPU. So this is like a big disadvantage of Hummingbird. But what you get a neural network that can be updated with features and optimizations neural network offers, and it will not be applicable on XGBoost. So now we have done all the things. So let us move to the practical part. So as you can see my screen, we will go to Google Colab and check how it works. So you should try parallelly with me. It will be good to get everything understood.
ये मैं कर लेता हूँ, आप जब तक ड्यू लैंड।
खोलो Chrome. Yeah. So we have Hummingbird here. Is it loading? आवाज सुनो. Yeah. So first thing first, you should have a PyTorch library of version newer than 1.4.0. That is the prerequisite. Then we will install Hummingbird, that is the version 0.0.6. So we will run it here. But we forgot one thing that is very essential. Go to runtime, change the runtime to GPU. It is already in GPU, so we don't need to change anything. We should cancel it. Now it is initializing first, then it will connect, and then we will proceed. Yeah, so it is connected. And now we are installing the Hummingbird library 0.0.6 September version. So yeah, it is already installed. So you can see here. Then if you do not have a PyTorch version of better than 1.7.0, then you should install it. And this is the code you have to run. But I have already satisfied this requirement, so I don't need to install it now. So now what we are doing is that we are importing a breast cancer dataset and pandas library to work on it. So we are allocating the data to different variables. You can see the data here. Then we have the outputs here, the labels. Then we are importing random forest classifier, and we will try to convert it to PyTorch framework with the use of Hummingbird. So let's run it. Random forest is a algorithm which is present inside a ensemble library. And then what we are doing here, we have a random forest classifier, which is a bagging technique. And what we are doing, we are using an estimators 500. That is the number of decision trees we are using. That is 500. And up to what depth? We are using a depth of 7, like how we are connecting decision trees to decision trees, like up to what depth we have the decision trees. Then we are training our model with the x values, that is the training, that is the data, and the output. Then we are predicting the, like, first we should like predict it. It's fitting now, it's fitted. Okay. So now what we have, that we have to predict the output in the scikit-learn model and in GPU. So we will see what time we get. It is taking 52.2 millisecond per loop, which is the best of three. Then what we are doing, we are importing hummingbird.convert model. Hummingbird.ml is a library and convert is a function present inside hummingbird.ml. So now what we are doing, we are converting our sklearn model to a PyTorch framework using the convert function provided by hummingbird.ml, and we are storing it in a variable model. And now what we have is the converted version with Hummingbird, and we are predicting it with CPU. So you can check what time it is taking. Oh, we have not run it. Run it. So you can see how much time it is taking to get the output, which is 22.2 millisecond. If you can compare it with 52.2 millisecond, it's like half. Then we are going to use GPU for using it as a hardware accelerator in our Hummingbird model or a PyTorch framework model. So we will see here what time it is taking. So yeah, it is significantly small, which is you can calculate it. It is like 50 times faster than what we have seen here. Here, with scikit-learn model and CPU as a hardware, we got 52.2 millisecond per loop of time optimization, and what we got here is 1.13 millisecond per loop, which is significantly great. And if you want to check, is there anything changed in the output, we can check it. We are getting both the outputs with the sklearn model and with the Hummingbird model in predicted.gpu and predicted sklearn. So you can see the output here. That is 99.84%. That is same both for SQL and for Hummingbird as a GPU. So from here, Pranav will taking us the part and will show you how to use a Streamlit library as an app framework and the deployment phase using Heroku. But before that, I will like to tell you all guys that we are going to organize a hackathon, that is the Green Hackathon, in December, which will be sponsored to which will be sponsored by Greenpeace India. So I'll be looking you guys there. Okay, thank you.